if we can recall, earlier in our studies, we learned that we have repeated products. That is, when we talk of the likes of 3 times 3 times 3, we can represent these 3 times 3 times 3 by 3 raised to the power 3. The same way, when we have 5 times 5 times 5 times 5, we can easily represent this by 5 raised to the power 4. Now, having 5 raised to the power 4, then we can also see that the 5 over here becomes our base. Then the 4 becomes our exponent. So algebraically, we can say that A times A times A would give us A raised to the power 3, where 3 here becomes our exponent, and then A is our what? Our base. So in general form, indices is represented by A raised to the power n, or A exponent n, where n here becomes our factors. So the factors of A is n. So expressing this as a power, we have 4 factors over here, 4 different types of 6 that are multiplying each other. So since they are 4, we just write 6 and then raise it to the power 4. That is how simple it is. Also, expressing B raised to the power 3 as a product is as simple as it can be. We have an exponent of 3 here, so we just multiply B 3 times, and that is going to be our answer. Also, let's try solving this question, where we have A squared is equal to 25. So if we have A squared equals 25, what we are supposed to do here is we are supposed to change this 25 to a number that is having an exponent of 2. So we change the exponents equally. We are going to get A raised to the power 2 equals 5 squared is 25. Then, since this squared and this squared are here, they cancel out. Then we have A would be equal to what? 5 as our final answer. Now, with the laws of indices, let's consider this expression where we have 3 raised to the power 2 times 3 exponent 4. Now, with this expression, what we are supposed to do is, a law of indices states that whenever we are having a multiplication of the same basis, so whenever we are having a multiplication of the same basis, that is, if we have A to the power n times A to the power m, what we are supposed to do here is we add the exponents. Adding the exponents will give us the same A as the base, n plus m. So this is how we do it. And then, taking into consideration our question, we are going to get 3 raised to the power 2 by 3 raised to the power 4. This is going to give us what? 3, then we have 2 plus 4. Then we have 3 exponent 6 as our final answer. So let's take another example where we are going to have A exponent 5 multiplied by A exponent 3. Now with this, it's the same rule. We take the same base as our A, then we add our exponents, where we are having 5 plus 3. This is going to give us A exponent 8 as our final answer. Beginning quotients. Now with quotients of indices, it's very similar to multiplication. This is where we have A raised to the power n over A raised to the power m. Now with division, that is quotient, division we subtract, and then multiplication we add. So what we are supposed to do over here is a as our base, then n minus m as our exponents. So taking into consideration an example where we have a raised to the power 3 over a raised to the power 2, this is going to give us a3 minus 2. Then we are getting a, which is a raised to the power 1 as our final. So taking an example like 7 to the power 4 all over 7 to the power 2. This is simply solved as 7 exponent 4 minus 2. And then this is given as 7 exponent 2. So that's the basic law of indices regarding quotients. So the simplest way of solving this is you are supposed to differentiate the numbers from the letters, where we are going to have this 5 multiplied by 6, then multiplied by a exponent 3 multiplied by a exponent 4. Then you divide all of them by a exponent 2 multiplied by. Now this is a tricky part. This is where we are multiplying this a exponent 3 by 2. So this 2 here would multiply the exponent, but it wouldn't add. But if it is in this form, that is when we add. So with this, we are going to get a exponent 3 times 2. That is what the bracket is for. Then simplifying this, we are getting 5 by 6 is 30 multiplied by a raised to the power 3 times a raised to the power 4 is giving us what? A raised to the power 3 plus 4. Then this will be divided by a exponent 2 multiplied by a exponent 6. And then this is 30. A 3 plus 4 is a exponent what? 7 over a exponent 2 multiplied by a exponent 6 is giving us a exponent 8. So with this, we have a quotient. And then with the quotient rule, we can now say that this 30 is divided by 1. And then we have a exponent 7 over a exponent what? 8. Then this is giving us 30 a exponent 7 minus 8. And then you get 30 a exponent negative 1. And then whenever a number is in the negative form, what do we do to it? We bring it down beneath a quotient line. So we are getting 30 over a as our final answer.